Okay, we have some of us already connected, so I will start. My name is Andrea Padre. I am the cluster manager from CICA, that is Catalan Lighting Cluster. We are a member of Sileo project, and as you well aware, from Sileo we have different initiatives, and one of them is this online masterclass. In this case, we are organizing one focus on big data and artificial intelligence. In this case, we will present the description of what is big data, what is artificial intelligence, what types of artificial intelligence we have or are becoming relevant nowadays for lighting and furniture sector, and also some of the use cases from different companies that could be related to lighting, to furniture sector, or to other sectors that could be adapt also or work for our industries. In this case, the webinar will be managed, and the speaker will be Carlos Cosials from Integral Innovation Experts, and also we have the collaboration of Elisenda Martí. As you know, the project Sileo is a project that the consortium is composed by 7 industrial lighting and furniture cluster. In this case, we have ELCA, Cluster Lumiere, our CICAD, Lucin Veneto, BIG from Austria, Transilvanian Furniture Cluster, and also Cluster Arredo. So if you need to have contact with some of the clusters, you have here all the contacts. And also I would like to inform you that we have some lump sum projects for the companies, the SMEs from Europe implement new technologies. We had opened 3 different calls for implementation and consultancy for these kind of technologies, and the last one will be on September. So stay tuned to our project, and you will learn how to apply and what is available for and eligible for that kind of last call in September. And that's all from my side. So please, thank you and enjoy this online masterclass with Carlos Cosials.
Okay, thank you very much, Andrea. I will share my screen. Say hello, everybody. Okay. Yeah, you see in the screens?
Yeah.
Yeah, great. So hello, good morning. My name is Carlos Cosials. I am working in the company in Integral Innovation Experts. I also directing a executive master in one University of Barcelona related with data science and analytics. And well, together with me in the background is Elisenda Martí, as Andrea mentioned, that they collaborates with me in the master. So if it's required, she will attend also meeting with some questions. So let's go through the contents. Well, first of all the slides will be shared, so some information of that. Very briefly, this is my introduction. This is my profile on LinkedIn, and basically I am a computer science guy many years ago. But since then I've been always in the side of technology, pushing with the technology to help the companies, mainly industrial companies, and quite focused on the development of products. Saying that, I put you this slide as a disclaimer. This is my way of thinking about what it's today products. Okay. I don't know if you are aware about what is digital twin, but this is one of my focus of interest in the industrial companies. So inside are many things there. Okay. But let's say that the focus on the master of today will be in these areas. Okay, that is where basically the machine learning, understand that one of the techniques of artificial intelligence could be applied. We will have this agenda for today. And well, I put this dotted line because more or less, my expectation is in the 1 hour and a half, 10:30, we made a 10 minutes break to fresh the air, to fresh the brain with fresh air and drink something and whatever, to rest a little. Because the session is so long, waiting for the end for question will be so difficult. So in any case you have any doubt, you can interrupt me. As you will see, let's say that the content is split in two. This will be the first part where we will review concepts. Maybe the idea of this master, a small master, is to give you some introductory knowledge on what is big data, artificial intelligence, machine learning, and all these topics. And let's say the second part is more oriented to where it has been applied and some clues and recommendations about how to adopt that inside the company. And I will try to refer always as the company who adopts the technology. You will see that in the part of the applications, we have split it in three main, let's say, scenarios. Is the referring to the value chain of the company, product, process, and for sales of service. I like to say sales. The sales process will be inside. Okay, we have split it in this logical value chain, even though the things or the activities start in different types. Okay. Well, this is the agenda. Okay, and first let's start with big data. Big data is a term that started many years ago. In fact, it started as a very technological concept, the application of that. And the idea is that today, let's say, the data concept or big data has evolved to intelligence and artificial intelligence. When we started with that, it was mainly a big data discussion. It was a very technological discussion. And all the concepts around where well, there will be a lot of data. And this raw amount of data will allow us to, to explore, to distill, and to gain, let's say, knowledge in the meaning of understanding of information. So taking that claim of information is power. So in the companies, power is always related with benefits. So, well, this was the idea. Maybe this wording has been, well, widely blurred, and today is more related on how to exploit. But at the beginning, the focus was in, well, at that moment, the forecast about how many devices will be connected through the internet will foster a lot of data. You should take into account that data, in the meaning of digital representation of a fact, before that it was made only by humans. That means it's a human that in front of a computer introduces, records some data. At that moment, the data was inside the machines. A fact that succeeds or happens. On the reality, is being recorded so that the data appears. So that means that at that moment, let's say the beginning of the century, data was produced, was generated by humans. With the advent of internet, and mainly the Internet of Things, the data explosion was forecast. So that's why at the initial discussions of that, big data was the main concern. Before entering in what is big data, maybe it's relevant to understand this pyramid of concepts. Okay, as you will see here, I have put some slides that tries to relate what is data, what is information, what is knowledge, and in some cases, someone talk about wisdom. This schema talks about knowledge, understanding, and wisdom. And wisdom, we can understand it, and something that I guess that in the companies it's very, very frequent. That is intuition. I guess. This is a wording that is I use it a lot of inside the companies. So well, we will be here, as you can more or less understand, and figure out here. When we talk about data is the basic, is the raw material with we started to generate information. Okay. Afterwards, we can have the knowledge. And why the icon of a brain is put here if related with knowledge? Because knowledge cannot be managed. Knowledge cannot be managed. Why? Because knowledge only happens inside the brain. Only happens in the brain. The knowledge is these aha moments. But we will see later. Okay. So let's start with data. If we need to talk about big data, we should start with data. So here is where what is data? So data is the minimum semantic unit, okay, of that correspond to the primary elements of information. Another way, it can be a set of values, a color, name, a phone number, name of a street, etc. This is data. Without interrelated one of the others, this is like we will say a value. 33. 33, what does it mean? You have to put in context. So well, this is data. With this red screen, well, some in our brains can start to blinking, okay? So danger could mean we don't know. We need more information. So what is information? Information is when all the data is combined and is contextualizing, categorizing, calculated, corrected, and aggregating all condensed. In this case, in this meaning, when information is made in this way, is when it starts to make sense. Okay. So yeah, if we put this red light inside of a circle, okay, this is what we will understand of information. You must stop. Or if you see this red light near to a industrial refrigerator, means that is working on, okay, or someone is inside, okay? So data plus context is information, okay? This is important because in the past or at the beginning of the adoption of digital technologies, the main purpose was to have information systems that later we will talk about, okay? But what is knowledge? So knowledge is a mix of experience, something that we have inside, and that give us the framework for incorporating new experience. So as the way we think, as the way we store the information in our brain, is how we gather new knowledge. And why is information? What is important in knowledge? Because it's used for action. When we go to the species, why human has made the colony of the world, because we are not the faster, we are not the stronger, we are the more smart or intelligent. So because we use our knowledge to do things. And this is important because if as we said at the beginning, information is power in the company, it is because it allows us to take knowledge decisions. We take decisions with the knowledge. So that's what important. What is clear that knowledge is derived from information, and information is from data. So you want to arrive to knowledge, as we see in the previous one, is that what information starts from data. A lot of data is what, let's say, will help us to have better information. Okay. So when this information becomes knowledge, it's necessary to take action: comparison, predicting, searching, or conversation. This very human activities is what we will see later, is what is being the main purpose of the artificial intelligence. So here we will see some equivalences. Okay. So when we drive, it is clear that we need some information. Where are the cars? Where are the signals? Where are all the contexts? Where is our experience? And that give us the knowledge, together with the driver license that we acquire at the moment of being credited to do. So as you can see, this comparison is not the same to drive a car that having a driver license. You can know how to drive a car, but maybe you don't get the license to drive because you have to follow some rules external to the car. So that's important, that this knowledge will give you the ability, capacity, and credentialing to yeah. We have talked about data, information, and knowledge. This is a very, very starting point of overview, okay? Saying that, well, I would like to make a joke with you, okay, about data and tools, because when we are talking about artificial intelligence on big data, we are using some tools for that, okay? Let's start with the data inside the company. How many types of data do you think they are? Well, they are digits in the setting of numbers or text, but also they are drawings. All the companies of you that work with your defining your product, you use drawings, maybe in 2D or 3D. So this is part of the data you have to manage. There is the code. So if you are creating a smart product, you will need to add this data, text, lines of code. This is part of the information you have to manage, or the type of data you have to manage. And if you are working with social media, or you are working with your catalogs or portfolios or whatever, you have to manage images. So this is another type of data. But also you will have many images working, many images playing. So all these kind of audiovisual. All that, maybe we can discuss if there are more type of data, but basically all of that covers what we will call data. You have drawings, you have numbers about financial figures. You have text about description of a product or descriptions of customers, streets, addresses, whatever. All this is what we will consider data that the company has to manage, okay? Because they are produced internally, or because they are acquired, or because they are produced outside, but are interested for you, okay? So this is a type of data. Let's see how this data is related with information. We have seen a different type of data that could be related with different type of information. And here is when information systems arrive or take place in the company, and these are related with much more with type activities. So what or where it start? Everything starts with the accountability of the account, the finance account, and this has this, let's say, administrative perspective of the company. We have to manage the company. So we have to manage, we have to make the administration of the company. So for that, there are responsibilities. So because we have to be responsible, the ability to answer, responsible, we need to gather information to make, to produce or to give the correct answers. But what is happening that the products are starting to be also smart. So we have also products that are producing data. Here maybe it also lacks operations. Every product generates data in a service or not. Every activity inside a company that maybe in the past it was not relevant, was not recorded, but now, yes, we need to record how a machine that we have acquired and put in our premises is being producing data, or we need to know when a person enters and goes out, not only for the administrative purposes, but to know their productivity, etc. Which other let's say scenarios where it can happen in the applications. Take into account that this is the traditional perspective. This is the new, because we have products smart, so we are gathering information, but something that is coming more and more to the companies is that we have produced our own e-commerce. We have produced our own system, whatever. So here is where the application also is an information system that we have to manage. And well, I mentioned it before, but I have separated here is more about the operational activities. So all these type of activities produce their type of information. Remember, the information that is produced in this type of activities is a bunch of data that will relate together. And as I mentioned before, knowledge, what we trust, these are, for me and for many people, is here. This is where the knowledge is, let's say, created. When you, as a person, you relate in your manner all this information. And this, let's say, these connections is what, let's see, later we will see that artificial intelligence tries to, let's say, copy or at least emulate. Yeah? We have seen all related with data, but the other is tools. What I put these two very simple tools, because tools has also evolved. These basic tools, the humans, we started with these basic tools. We have applied to them. So we have usage of that or applications. So applications is to gather some kind of technology, hammer, knife, information systems, and we create something. So the technologies when appear that application of the technology to some tools. Yeah. Well, this is a very strange product. Okay, I had never used one of them, but well, the idea is that the usage of the technology with some concrete tools produces us some data information. The usage generates these evidences that we want to gather. Okay. So in this perspective, well, I like to make the joke of that. Anybody of you know what it is? That if someone knows, please put it on the chat. Okay. So well, this is something that I like to say. Well, to introduce the next one. That is, well, basically all this data producing and gathering that we are able to do is because sensors has been being deployed everywhere. Remember, the previous century, data was generated because it was a human that in front of a PC with a keyboard or whatever was typing and recording the data. What happened with the sensors appears are very affordable and can be deployed everywhere, and we connected that to the let's say internet. So we are able to gather a lot of signals. And here I forget to put the reference to the book. Well, I like this book because this woman is a technology that is talking about signals are talking. We will see during my presentation that the word talking will appear many times. This ability to sensorize everything is what is being represented on the mobiles. So mobiles are, let's say, the way as we as humans are becoming sensors. That's why social media, science, citizens as a scientist, whatever is something that is being coming much more usual as before. Okay, so think about that. The mobile. Let's say we are in the mobile, let's say, era. Another devices appear on the panorama and could be the new way to interact. But this is something that we'll see later. Is that is provoking the fact of having a lot of data. Yeah. No one says what was this device, but if I put that images, maybe some of you know what it is. This device. This device in that series Star Trek, it was called the tricorder. So at that moment, at that idea, yeah, it was. There is a guy asking. Maybe know it. Sorry, I see that the hand raised so late. It's okay. The person who raised the hand. Okay. Well, okay. So, well, the idea was that in that moment is to have a device that connects with the world. Okay. So let's see some figures about big data. What is big data? Well, it can be seen as the growth of data. How to express this mastodontic growth of data? Well, one way to represent it is via the names that we use to name numbers. Maybe we are more frequent today about giga or terabytes, but as you can see, maybe you or some of your sons, or maybe some of your grandchilds could finally use that. Here I put some of the figures that are usually applying this company. As you can see, well, it was, I don't know who decided that or who stated that, but 1 brontobyte will be our digital universe tomorrow. I don't know when tomorrow is the state. But as you can see, when we talk about big data, yeah, the sizes of the amount of data managed, stored, processed, it's relevant. And when I say processed, it means also, but in the unit of time, how much data is produced per unit of time. And here I put this infographics. That's company that always tries to gather is how much data is produced by unit of time. So that's why storing it, making it persistence is what will be the first approximation about big data. Is a large amount of data in a very few time produced. Also, others say that big data is the timeless statistic, the same as always. Techniques, and that's why Elisenda and me in the master, we always talk about this is more a technical aspect than technology aspect, is because, well, here statistics apply. So yeah, it's also a new technology. In part, partially yes, partially not. In fact, there is maybe the technology changes in the way to represent. The mobile was the last way to manage or represent the information, not store it and process it, that it will be on it. So, well, it is more or less a common agreement that, and here there are others that talk about much B there, that big data is related with these 4 dimensions or 4 B's: volume, variety, velocity, and veracity. And why they are important? Because as we have seen, when the scale of data is huge, this is something that we have to manage. How to mobilize, how to store, how to, in general, manage this amount of data. Okay, this is important. Here, what happened is that the price of the hard disk has downloading, the price of memories has downloading, has been reduced, sorry. And if you also put it on the cloud, you have some economies of scale. So, well, this is what the price of storing data is decreasing, okay? What also is happening is the amount of data that is being produced per unit of time is growing, because you have faster sensors to capture information, to capture data. You have faster or powerful smartphones to gather more pixels. So in the one shot, you gather more pixels. And this pixel you later on should send it and store it somewhere. So these are the more, let's say, understandable. But also, as I showed you at the beginning, the type of data are very different. It's not the same managing a matrix of pixels that represent an image, or a bunch of matrix of pixels that will be a video, together with the audio that will be also recording there, comparing with drawings, referring to some vector information or whatever, the drawings, etc., etc. So all this diversity of data means that you cannot have let's say, a standardized way to manage that. And last but not least, and social media has promoted that, is not everything that is being digitalized is true. What happened in the last century when there was a person recording the data? Is in the same way as all the systems of registry exist. You go to a place where was a person authorized that record that on this book, in that digital book. So the person that was there was one the responsible for state the veracity of the data. When you free to everybody to record and put and publish data, what happens is not all of that data is real. So you have to manage with all of that at the same time. It's not one in the opposite of the other or whatever. You have to deal with that. And yeah, that's what I mentioned before, that there are some people or some authorized voices that talk about that. Here I put a video confirming that you can, and yeah, that's the problem. When I have that, it doesn't work. Confirm me, please, that you can hear the video.
Yes, Carlos, we can see.
And here?
Big data is everywhere, and
Yes,
more and
yeah,
more applications are created every day to extract value from it, enriching both our personal and professional lives. In many ways, big data is born out of the sheer pace at which data is generated. In fact, some analysts expect that by the end of the decade, the amount of data generated will be 50 times the amount of data today. At one hand, this deluge has been greatly accelerated by things like the growth of scientific data. Consider, for example, the atomic physics experiments at CERN that can generate 40 terabytes of data every second. On the other hand, this deluge has been led by some very positive social and economical changes in our society. Consider, for example, the rapid adoption of GPS-enabled, media-rich mobile devices and of social networks that has digitally linked billions of people worldwide. Together, they have enabled a new way of living through spontaneous, instantaneous, and almost constant exchange of data among individuals. These and many more emerging new ways of doing things, of living really, are today generating data that has been loosely classified as big data. One of the not-so-secret secrets about big data is that it is fueled by the very properties of the cloud.
Yeah.
In fact, it is the attributes of the cloud, such as economies of scale, affordability to the masses, agility, and extensibility, that enable us to create big data and to tackle its challenges. And in turn, the very big data demands drive future designs, enhancements, and expansions of the cloud, all in a never-ending cycle driving both forward. Simply put, big data challenges expose all of us to the details and limitations of the underlying information infrastructure and pushes users to seek thought leaders and to force them to experiment and move to the next generation of breakthroughs. When that happens, people can solve problems they previously couldn't. They can take on challenges that they previously wouldn't. EMC today finds itself positioned at the intersection of cloud and this avalanche of big data. And because of our unique position in the field, we get asked questions all the time, like, how big really is big data? This is actually a very intriguing question whose answer seems to lack consensus at the moment, but whose ambiguity has not stopped the use of the term. A common misconception, however, is that big data refers solely to the size of the data. If it is data and it is big, then, well, it must be big data. While size is certainly an element of the equation, there are other aspects or properties of big data not necessarily associated with size. For example, consider the speed at which big data is generated and the number and variety of sources simultaneously generating data. Let's take a look at each and see what really classifies different data as big data. I think we would all agree that a 40-megabyte PowerPoint presentation, a terabyte healthcare image, or a petabyte move are all big. But the question at hand is, are they big data? I could argue that they are not big data simply because of their size. What is big today, hey, may not be so big tomorrow. But I would argue that they are big data because each pushes to the limits the common technology available to utilize them. A 40-megabyte PowerPoint presentation is big data when you cannot share it via email with a colleague or customer. A terabyte healthcare image is big data when you cannot simply and accurately display it in a remote screen in real time for a doctor to use in a consultation with a patient. A petabyte movie is big data when you cannot render edits within the time constraints of the business. So that was a good start. We demystified the number one misconception, which is that big data is just about size. As we see, big data is really about any attribute, size being one of them, when it challenges the constraints of a system's capability or business need. But what about the other attributes like the speed at which data is generated or the number and variety of sources that create it that can fit our definition? This is where the big data classification can be applied to data that is not, by itself, big at all. Some of these can get their big data classification based on volume, as they are being created by aggregating many fragments of small data that are somehow related, and the large set of these fragments then define a big data. These volumes can be seen, for example, in the context of the smart meters that are being deployed in every home worldwide that send to the electric companies the energy generated and consumed in a household every 10 to 15 minutes. Now you can multiply that by the number of homes in a city or even in a small town, and big data refers to the sheer volume of data to be analyzed within a given time frame or within a geographical boundary. Big volumes of data can also be found in logs, where a huge volume of entries for a system, when grouped together, create an instance of big data. Or it can be found in a transactional world, where many transactions together generate databases containing big data. Another interesting aspect of big data is that not all big data are the same from a structure perspective. Some big data have its format well defined, like transactions in a database, where each entry can be divided into fields, each with a well-defined and understood data type. Some big data may just be a collection of blog entries that contain text, tables, images, voice, and video, all kept in the same data storage. Which leads us to the final aspect of big data: generation diversity and interconnectedness. Big data generation ranges from automated generation of information by applications, such as images of weather predictions, to manual entries, such as people videotaping portions of their everyday lives or typing entries into Twitter. Big data also gets updated at an amazing rate in a very iterative and incremental manner. Changes to the data are generated constantly, and the data gets more accurate, more precise as time passes, and more data about the data is created, calculated, or inferred. Despite of the size, speed, or source of the data, or portions of the data, big data drives the need to make sense out of the chaos. Big data drives the need to find meaning on the data that is constantly changing and to find relationships between the data created. Understanding this interconnectedness and being able to harvest the information hidden in big data unlocks big data's value, which can only be gained by being able to tackle our own big data challenges. Collecting, analyzing, and understanding big data is becoming a differentiated strategy today, but it will become a fact of life tomorrow. Running analysis at the finest granularities, while still having enough data for the results to be meaningful and accurate, leads to more precise action and, in turn, more profits and savings for the company and customers. So when it comes to big data, the question actually is not, why should I care about big data? But how can I get closer to big data? And how can I start taking advantage of it now? EMC technologies empower us to get started on the road to unlocking all the value that resides in our own big data.
Okay. So some words there. Some words are regarding about why big data is a new paradigm. You have seen and hear about volume, speed, that is related with the velocity, value, action, etc. I like, even though it is a very, very old video, it represented very quite well that at the moment was understood as a big data. As you can see here, it's not talking about generative AI, it's not talking about algorithms, it's not talking about models. This is something that we will talk afterwards, okay? But, well, I liked this video because at that moment, big data, and this video was produced by one of the companies that sell hard disk. This is EMC. It's a company that held this hard disk and was very interested to promote the acquisition of their hard disk, because it's expected that if you want to achieve all these expectations that the video are showing, you should start save as persistent data. Okay, so yeah, let's review more or less where the data is generated. This is the kind of infographics that at the beginning of the century what promoted a lot, saying there will be a lot of devices connected. I showed you before one of others. And here, yeah, the idea is that this is growing. I have this more updated forecast. Here is talking about IoT again. It's trying to separate, because nowadays we know that not all the connections, not all the wireless and not the wireless connections are the same. So a different type of connections and different type of mechanism to gather data. If the wireless networks are very ubiquitous today, that means that we can have data. If we have a sensor in the middle of a mountain and there is an antenna that covers this sensor, data will. So from our perspective, I mean the perspective that we are here, I gathered this information, these slides. The company where I work, we work with a company that's called PTC, and PTC is this software you can see here is Parametric is one. Okay, it's one of the CAD tools to design and make the definition of this physical product. And my statement here is Internet of Things allowed you to make that your machines, your products talk. And well, how to represent that? Well, I don't know if you know that. You know that about Ori? Someone of you know this experience? Well, it's a very short video where you can see how these guys, let's say, are interacting or talking with this machine, this furniture. This concept of routines that you can put in the mobile. Alexa, our friend Alexa. Start this seminar today with this video, where you see many things here. It's the furniture, in Spanish we say mobiliario. The mobiliario moves, so that's what it's called, mobiliario in Spanish. The furniture is moving, okay, and your users, not your acquisition, your users, because they are using the devices. Well, here there is some part of videos. I don't know where we put it because, well, they are very short. Where you see that the voice, common voice is
Alexa, start my day.
Good morning. Currently in Toronto, it's 15 degrees Celsius with clear skies and sun.
Alexa, give me a compliment.
You're so funny. You could make the Mona Lisa smile.
Alexa, turn on the reading light.
Okay.
Alexa, announce it's time for bed.
Announcing.
It's time for bed. Alexa, turn the lights off.
Okay.
Alexa, the perfect bedside companion to help you start your day right and wind down at night.
So Alexa is your partner. And I put the videos of Alexa. There are others, not so much. Previously, you see Ori Systems, that is being let's say, the commander of the furniture, the lights, and whatever. So here is the battle. So you, as companies, you have to know and have to be aware that you are not alone, in the good sense and bad sense. But this is a small video also, where it shows how.
Alexa, let's chat.
What's on your mind?
How did my soccer team do yesterday?
Yesterday, OL Reign won 1-0 against the Portland Thorns.
Can you give me a recap?
Your team was steady all through the first half, with a strong defense and 52% ball possession. Things got heated during the second half with a foul that earned the Portland Thorns a yellow card. OL Reign scored the first goal in the 55th minute.
Yes! Let's celebrate. What's a new pop dance song?
Hot to Go by Chappell Roan is popular.
Cool, play it.
Sure.
5, 6, 7, 8.
That was fun. Hello, old friend. Alexa, every Wednesday morning at 8 a.m., turn on my bedroom lights, set the thermostat to 68 degrees, and play my running hype playlist.
Okay, I've created this Wednesday morning run routine for you.
Thanks. What are some fun themes for a dinner party?
Tiki, Under the Sea, Casino Night, and Masquerade are all popular dinner party themes.
What if I want to host a murder mystery night?
Great idea. Props and ambience are a good place to start. Popular props include costumes, candelabras, and colorful LED lights.
Love that. Can you draft a message inviting my friends to come over for a murder mystery?
I will jump the video, and you can see later more in detail. But what was my intention to show here now, this video, is that your machines should talk. And talk means that you should jump from the traditional engineering perspective of functions of your product. Your product makes some, facilitate some functions to the users. And here what happened is that you have to prepare your product to be able to talk with an intermediate in this broker that could be for you, Alexa. And you have seen that the users are creating kind of routines. Routines means a bunch of orders or commands or prompts that are now I say in generative AI. So think about that the wall is being every time more open than closed. Why I like this image and share with you, because in a traditional way, we think about the product as of something that we decide what happened with it, and we close the functionalities. But nowadays, we are talking more about futures, because we are in an open world. IoT has facilitated that, and here is what is being becoming, because the cloud itself is being fostering that to all the different devices connect on the cloud. Here is where the big data is being happening, and then the devices are being, okay? So first of all, where the data is generated, the data is generated by your devices, is being managed, brokerage by a partner from you, Alexa, Siri, Google, etc., or other partners that has like Ori, and they are generating data from every action that you ask or your customers ask your products to. Okay, where more data is generated, as we see before, people is generating a lot of data. All this social media, all these conversations that are being applied there. You have seen that in the previous videos that the girls were talking. So we're having a kind of conversation everywhere, even though it's very guided. Okay, so this is what is being done. And here what's happened, that this social media is what it relates to the beginning, all these images, text, and interconnections that are being produced by people, our consumers, our influencers, whatever, they are generating data. This data is not our data, but is data that we should care about that, and care to be interested in to process, to bunch it or package all that. You see in the video of EMC that they were talking about structured data. Normally it's the data that we produce inside the company. We record and produce a structured data, but if we want to proceed with all this data, we have to gather and put it together with the structured data, and that creates this variety of data that we mentioned at the beginning. Okay, that will say that, well, this is my first introduction, or it's my introduction, or in the first step to, let's say, set up the concept about big data. Today we are talking more about artificial intelligence more than big data. Why? Because, well, data and managing the data has been, let's say, it's more a commodity. That's why these companies, these hyperscalers, some of them mentioned, Microsoft, Amazon, Google, all these companies that manage the cloud and has the ability, economically profitable ability to manage a lot of data. They earn from us to manage that, this ability to do. So today is more related about, well, how we take profit of that. For that, we have to go to the basics, to the basis of the all these techniques. And Elisenda and me, we normally use this slide to set up concepts. Regarding we have seen about the big data, okay? All these technological aspects of data. Data science that will be more related with let's say statistical aspects, how to manage data, but not manage for records or answer, but manage information statistically to understand, and understand means analyze it, and all the techniques, the kind of algorithms that exist to manage that. These three parts, we can see it in different ways. Here you see this will be the concept of data science, the concept of big data, managing a lot of data, and understanding the issue. Understanding the issue, not all the issues, all the challenges, all the scenarios that we want to manage are the same. Even in the same scenarios for different sectors will be different. Okay, so yeah, this is something that you have to have in mind, that when we go inside data scientists or data science, understood as the techniques to apply artificial intelligence arise. Well, this is another way to see that. I don't want to go inside, but yeah, this I like this graphic because behind or envelope that is the concept of circularity. You are, as any business challenges, you are always improving, you are always turning around. Yeah. And well, a small remark, because there is sometimes there's a small misconception depending on the size of the company, depending on the roles. There's different roles inside the company, but I have bold that business analyst because normally is where confusion are. And we will see later why this confusion are, because let me advance to you some, is when we are analyzing the business, we are looking backgrounds. When we want to state for a data scientist, we want to go to look forward. This is a, let's say, retrospective perspective. What had happened with our business, and data scientists is what we want to know for the future, what we want to predict more than less. Additionally, nevertheless, is that's why we talk about that this is a technique more than a technological aspect, the artificial intelligence, because you need for this person that will be involved in the activities of data science to have another skills, not only technical skills. That's why we talk about techniques. So, well, these guys have to be curious, have to be critical thinking, not believe in all the data that happen, and understand them, and Why it's important to communicate? Because the models is the hard part of the creating an analytical model. But yes, afterwards you have to explain. Yeah. So let's go deep in this understanding of this science of the data, meaning statistical science. Science is because you can represent it. As I mentioned before, when we talk about this analytic perspective that is inside the artificial intelligence, we have to have this wide perspective. As I mentioned before, everything started with the raw data. And let's say that this dotted line, what tries to describe is that we are here in the timeline, we are here, and when we go back, when we go review what had happened, is what we want to and explain. Explain means to describe what had happened, and this is what we do with the traditional tools to make this, let's say, business intelligence activities. But artificial intelligence, let's say, will start from here forward when we want to make some prediction, or to explanation, sorry, to explain automatically what happened, make some prediction, or even though make some prescription. Okay, this is we will say later another graphics that always try to represent this the same. So here, sense and response. This is what we do with, let's say, traditional way to manage the data. Here are some rules that we want to identify, and here, let's say, we don't know the rules, and we want to explain what happened through the behavior of the data. Normally, in a traditional perspective way, we as humans and we as companies, organizations, we run by rules. Rules means I know what to do, I know how to do it, and it is important. If I know how to do it in a scale, I can make a big company because I have the knowledge on how to. And the what was less important than about how to know. Today, what happened is this: the things or how to do things, or how to produce, how to do these roulette activities are very supported by information systems. So the knowledge is being inside the systems. And what is important is that systems, information systems, they produce data, and to gather this data to understand why happened or what will happen. So looking at the future. This is usually the framework reference that when we talk about artificial intelligence, we state machine learning. I will sometimes use artificial intelligence, and sometimes I will use machine learning, as you see in the previous infographic. So in any case, we have these signals, this raw data that is being gathered without specific criteria or specific criteria with our specific purpose. We gather, and then is when they start all this process that data scientists will do. First, has to understand, learn about the data, to understand what happened. With that, it's when a model, model means that, in English has been called machine learning, that this process of learn that we have done as a human is being able to reproduce in a mechanical way, and it's called machine learning, to produce this predictive model. Okay, and afterwards, as the science happened, the science is the example of how new discoveries, new evidences maybe change or the statement that was before sobre over and a situation or a scenario. So here happened the same. Every new data could modify the model that we have. Okay, this is the common understanding. So learn, predict, and adapt. So that means that every model that make an inference, that make predictions over the future will be which should be to be adapted to the new situations, scenarios, new data, new processes, whatever. So this is not something that remains immobile. Okay. So going just deep on that, how is the process to distill? This is alchemy. Sometimes we talk about this data science act as an alchemist because they gather the different data, they got the different type of evidences, they put it together, data, information, and with this information, what they maybe sometimes need to produce a new type of data. And later I will give you some examples. And with that is when I can state for this machinery way of producing inferences, machine learning. Here I have learned about the data, and with an algorithm, with a sequential way of processing this data, I will inference some decision, I will inference some information, graphically and understandable, intelligent, that give to the consumer new perspective. Going more in detail, okay. Normally what is being done is all this diversity of data. After analyzing, we put it in a structured way. That's why we made the feature engineering. What is a feature engineering? For example, imagine a company that they are having their services of their operations, and the operators that are in the telemarketing, they enter to work 10 of the night, finish the next day at the first shift at 8 of the morning. The concept of what is a day, well, the day, all of us will say, day is what started at 0 a.m. and finishes at 0 p.m. Okay, so this is a day, but this natural day is not the same as the operational journal of the operators. So you have to, if the data of when the operators enter and go out is being recorded on this way, you have to reproduce the data to say, no, this activity belongs to this day and this activity belongs to this other day, even though it has been recorded as my journal. Okay, there are many bunch of examples. Okay, I start a session to acquire a product in the web. I started at 11:45 p.m. but I finish my session of acquire at the next day. If I want to, let's say, having the productivity on that, how I split that operation of acquire in my e-commerce. In some cases, I will say that no, not finish it and not start it, but this is not right. So these kind of small scenarios, when you gather all the information and you try to put it in a way to explain it, is when you have to create this feature engineering. This means I have a new information. Take care that the word feature here inside artificial intelligence is used in one way, but later when we talk about products and systems, feature will be meaning in another way. Once this is ready is when we create the different algorithms, and the different algorithms is what produces that. So this is the effort to understand the data, and we will see later, but more or less here is a Pareto. Every project of creating a model, let's say, in general, takes 80% in understanding the data, what data we have, what is the veracity of the data, if we need to produce a new feature that explains the phenomena that we want to understand. You take a lot of time, and later you create, let's say, the model. And here is when you have to select which is the best algorithm, the best way to represent what you want to represent. Or you want to represent clusterization. So you want to identify if a new evidence arrives, it's one of another, segments of customers, situation of a machine, it is on or off, whatever. Or you are trying to identify what is what will happen in the case of failure, what is the probability that this phenomena happens, or what is the neural networks that is today to use it to say this is equal to this. No, here is a Boolean, and here is more continuous about saying one of another. Okay, this is what we said, that this model of artificial intelligence is being created. Remember, first we have to prepare the data. It takes a lot of time. Why it takes a lot of time? It's not because of the person that have to analyze doesn't know. That sometimes happens. You are a data scientist, and maybe you are not familiar with furniture because you came from manufacture motorcycles in the company that was before. The main issue, what happens here, is that the majority of the data that you gather, you are able to manage, was produced not thinking about that it will solve your challenge. Okay, the data was stored for their purposes. The data was stored because I am a consumer. I go to my social media, and then I set or make the photo I want, I like it. You will prefer that, no, if I want to analyze, I would like that you put in the comments, I would like to put my reference of my product. If I am the user, I put my photo, and I say what I want. You are not on control of me. So what happened with that? That when you want to process this data, understand it in your context, it doesn't fit. You have to prepare. Or the other case is, well, it's data you produce it inside your company, but it was stored with different purposes of the one you want to produce. Okay, so that's why you take the majority of your time when creating a model to understand the data. The data you gather, let's say, never is prepared for the case you are. Okay. So saying that, okay, what type of different wording that maybe you have heard, what are the different type of artificial intelligence? Okay. Well, basically, the machine learning I apply it to processes. What we do, are apply it to the assets that we have. Asset could be your product in the customer premises is an asset, but also the machines you acquire to make something are assets for you. So machines doing things, your machine in customer or you acquire, all related with if it's good or bad, let's say. And here, well, also we can introduce that all these conversations with the customers are more close to the concept of quality guarantee satisfaction. And the other that is important is for moving those assets, you need energy in some cases, or your company or your customers are asking, hey, give me some values about how much I have consumed, or you needed to know internally. Basically, these will be the different cases or scenarios where machine learning is applied. For that, we have to start with well, we have started with the data, and when we have the data, we have to choose what is the algorithm. Why an algorithm? Because as I said before, in the learn, what we do is to understand what is the data. We decide, we establish what is the statistical behavior of the data. We are able to explain it in a experiment, that we call it. But later on, what you want is to reproduce mechanically in a machine way this statement, this inference. So that's why you need to have an algorithm that do that. That, well, very basically, as we see before, the regressions, classifications, and clustering analysis of feature reductions is to understand. And this other category about neural networks, that is another kind of algorithm. So here is the basic statistical concepts. And here is when we go with the statistical concepts and we apply it systematically, all data against all data. Very basically said. When you heard so about the explicability of a model, means that the neural network that has been decided, and this is, if it has this shape or this or this or this is the decision of the data scientists that decide that this is the type of neural network that will explain mechanically, as machine will explain the phenomena in the future, because has stated that for the past. As you can see here, there is another way to see that, and say, well, what influences these data scientists to choose one or another algorithm? Normally, it's data. Data is what condition, or evidently, but it's important to our students. With Elisenda, we always say the same: is you as a data scientist, I mean, as a scientist, you said what the data is stating. That means that you are not saying what is your opinion. Remember at the beginning what we said, inside the company there is a lot of intuition. So here what we want to promote is no. Intuition is good, but intuition does not always succeed in the explanation. Okay, so here the idea is, let's explain the future based on data. So data is what is able to give you the chance to explain the future. So depending on what data, what amount of data you have, and if it is, you can predict a category. If it is labeled, so you can go to a classification. If not, you go to a similar kind of data because you don't have labeled of that, or you go through a regression. What is a kind of example of clustering data that I always like to state? Think, you as a companies, okay, you exist because exist customers. So all your customers, the ones you have and potential one, the leads, is your market. The market is to this amount of companies or consumers you address. How do you categorize your market? I mean, when you make a sales review, what do? You said, well, let's review the sales. So you stay. First, you take your portfolio. Later on, you divide it by territories. And maybe later on, you divide by who make the sale. So your market is your products by your territories, by the sellers. This is the way you are able to explain your market, okay? Many examples of clustering is when all the salts has been made and recovered, and the data reveals, thanks to the data scientist effort, reveals that there is agrupations, there are aggregations, there are clusterings of similar type of cells that your previous criteria does not explain, because when you explain something, you explain it based on your previous criteria. So here will be this kind of clustering. You reveal some different, let's say, segments. It will be a kind of, for making this machinery, to make it in a mechanical way, that's why you need some techniques. That is the techniques to programming the models that make these neural networks or these aggregations or clustering. For that, basically, there are 3 languages. 2 of them are the basics for data scientists, Python or R. That is one of the languages that is used for this unstructured data that has many facilities to prepare the data. Remember, you take 80% of your time to prepare the data, so you need tools. And language programming are tools that you will use to manage all this data. And when you have to deal with structured data, business data, SQL is one of them. There are other type of SQL, the non-SQL for not structured data, or even though there are some graph models for finding relationships, etc. But well, with the 2 previous, you can have. Okay, so you decide which is the best algorithm. You program it. This algorithm with the concrete languages. You have the data. And you have your algorithm with that. So what you get is the model. What is a model? A model is the combination of this concrete data with this concrete algorithm. You have programmed this, create the model. So to model, what you do is to base always in historical data. All the inferences your model can state or produce or show always is based on historical data. So here we are not talking about gurus or people that is having intuitions. Okay, with this historical data, you build the model. You validate it with the validation data. The all amount of data you have it, you don't manage it. You split it always. Again, Pareto is a good friend here, and you take 80% of the training data is the data you have to train your model. That later you will validate it. That if your model have to inference something, you test it with this data that gathers at the same time. You cannot merge, or you should not merge different timelines or different scenarios, because you will confuse that. Okay, and you will optimize it. Optimize means the level of confidence that this model produces, it's enough for you. Sometimes at the first time it doesn't work, because there are some outliers, there are some, you are trying to represent so many things, it doesn't fit, okay? That's why in some cases of artificial intelligence, we talk about or generic artificial intelligence or narrow artificial intelligence. And once, let's say, this model building, sometimes we talk about the experiments. Well, I would like to say that this is made on the laboratory, this laboratory where data scientists are building up the model. Once it's been finished means accepted by the business, is when it is put it on production with the rest of the systems. Okay. Here I have, this is a very long video. I will jump, but you can see it later. It's an old video. It's not a very modern video, but I like it because it tries to represent another word that is synthesized. Remember at the beginning when I say I am Carlos Cosials, and later I say the digital twin, and here I say it is model and synthesize. Yeah. Here, what we are seeing is this video where we will see that this this manager, I don't know if it's an actor or a manager, I don't know, I'm not sure, but here is where it's showing how calling parts. Cannot be there. It's General Electric is now different, but it represents quite well this company. What was the challenge of this company? They produced that machines. Predict was a system they produced to gather the data and make some inferences. This platform, okay, allows to do that.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39, the number of start-stop cycles has increased by 27.5%.
Okay. Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing in my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
I finished here the video. The video is longer, you see, but we will see here. All this is happening here. This is a theatralization, of course, but it is a synthesization. That means that this man is talking with a concrete machine, the unit 6321. And all the explanations are referring to this product and all the information that is gathering from different systems is being synthesized, represent the behavior of the machine, explaining and forecasting, and is talking with him. There is a voice-to-speech representation, there is text-to-voice emulation, etc. So, well, I said this is an old video, and General Electric nowadays cannot. It's not a good example of a company that has succeeded on that. But for me, the video tries to inspire you on what technologies are available to do that. The video continues, and here you have seen here that the voice is the way to communicate. The voice, the video continues, and here you see that the man is putting this.
So what I'm going to do
so that
is I'm actually going to use this lens to get a much more immersive environment. So what we would normally do...
You see here, the tablet is not in their hands. That means that maybe this is closer to a role of an operator. He needs the hands-free to operate with the machine while it's being seen. The information is the same like before.
Go into the actual physical plant and look at the steam turbine itself,
with the
physical steam turbine.
Touching,
and from that physical steam turbine, what I would do there, let's make sure we get this to go. Right, what I would do there is I would overlay all of my digital capabilities
without a keyboard,
on the physical
without
asset,
touching, it's being
seeing
interactive.
exactly where the damage was occurring. Now, as I can't do that, I can't take us all on that journey. It's 6 hours away.
Well, I finished the video because it's not the purpose to see all the video. But for me, what is important is the technologies to interact with the machine are evolving, voice or augmented reality in this case, but behind the curtains, all this invitation is what you need to do with artificial intelligence, knowing that the device will be connected through internet, okay? So, well, this is what inspires me. What does it mean synthesize? We'll not review all this schema, but mainly what it tries to understand from an asset that is working on. We will see on today's session that it's 2 walls, digital twin, 2 walls, where you define the product and all the intelligence you introduce there, and when you have the product as an asset, and you try to gather all the intelligence about what is happening on that. Normally in the companies, this way to go closer to the analytics has been done through the business intelligence. That's why inside the companies there are a lot of reporting that tries to explain the past. The challenge is here and to make predictions. This is where the challenge is. The really challenge is on the companies, and this artificial intelligence wants to address. So again, looking forward or looking backwards, having this retrospective perspective, or having this foresight or insight perspective. Okay, as I mentioned before, 80% of the time is related to understand, and 20% is related to create the model. And for create the model, let's say we do it by phases. The first is to gather the information of the production or the operation, and with that we make this exploratory data analysis. The data scientists go to the data and understand what the business is saying that is happening through the analysis of the data. The traditional way, I go to the person and I ask how they do the things. No, here is give me the data, and I will understand what is happening through the data. I want to be objective, and I need to extract, I need to distill the happenings from the data. With that, I produce a proof of concept, I develop a model, I start in production, and I can make more than predictive model. It's not one predictive model that predicts everything. No, it's not the same inside the company. You will have all the people for all the topics. Okay, so basically this will be a process to generate an artificial model. And before to go in deep with the type of the different type of algorithms, I propose to having a small break now, 10 minutes. Yeah. So for that, I will start this. Wait, reset. Sorry. Oh. Okay. So we come back here in 10 minutes. Okay, and we'll continue with the content. I have to show.
Thank you. We'll see in 10 minutes.
Yeah, please. Okay. So, well, let's go for the second part of the session. Saying that any comment that you want to share with the rest, question, also welcome. Any mention, comment that you want to share with the rest of the attendees? Well, if not during the session, as I mentioned before, you can post in the chat some comments about that. Okay, so well, let's say very briefly. You will see now that there are some screens, some slides with a lot of text representing the type of algorithms. The idea is not read it and understanding, but do you get a flavor of what the different type of algorithms that are basically used in the modelization of the algorithm? Okay. So recap on seeing a way. Well, when we talk about the analytics, what we are talking about having this, let's say, golden opportunity. The gold has to be gathered and produce it there. So, well, what foster this need to having this artificial intelligence, or to apply in a more mechanical way the analytics inside the company? Well, the lack of this type of persons with this discipline. With the master, together with Elisenda, we are trying to push to the market much more of them. But well, it's people that is want to get trained. So we train them, and they enter what they are. Okay. As you are seeing, technology behind the algorithms is something it's not easy. You have to merge some computer thinking and skills there. You have to recap, refresh all the statistics. Maybe you someday in the past you have. So here, take present and real. Not always they scale. Not always, or at least you cannot. That's why previously I mentioned these narrow scenarios in comparison with generic scenarios. You have some particular data of some situation of a scenario, and you are able to explain that. and not always a scale. And last but not least, I mentioned in the past also that finally this model that you, let's say, produce, the model, you have to put it in production. And when you put it in production, it has to be interconnect with the rest. If you are, you will see later, you were having a chatbot. So this chatbot, of course, should, let's say, gather information from the rest of information system you have there. So if the interconnection with the other system is not good, you will have not a good, maybe you have a good model, but does not scale, does not integrate with the rest, so it's not productively, you cannot deploy it productively because it fails in the reality of the company. Maybe in the laboratory, you have enough good results. Okay, so this is something that you have to have in mind when you consider adoption of the artificial intelligence. Okay. Saying that, we review again the different type of analytics, and here we have differentiate between decisions and actions. When we talk about prescriptive, is that this decision is made automatically. I stop the machine because I know that will broke, and before the machine breaks, I stop the machine. This is a prescriptive decision. Predictive is I know that the machine will fail, or I know what it happened. I know that this was an extreme, a normal situation, and I know what happened is that collect all the data of this machine, and I make a distribution, or I make a regression explaining what happened. Okay, so this different approximation is the first one is that you apply the rules. That's why I bold here, is when you are applying analytics here is because you are trying to explain in the ways of we understand the wall of our machine, the wall of our activities, whatever, and you explain it through statistical process control, all these statistical techniques, and you start to correlate patterns of working, and these patterns are descriptive and diagnostic. So the patterns explain what you understand. Okay. For that, we will get also creatory rate. When we said before, you have to make some creatory engineering to create new features. New features mean new values that explain something. You will do it via this way. Okay. And this is the foundation. Right? That means before go to machine learning and artificial intelligence, you have to have a clear understanding statement of what happened. After that, you can go to the application. It's when you can make this advanced analytics. And we say that it's advanced because we go forward to do. Sometimes we say that with Excel as a tool, you can do that. Excel plus Power BI, and Excel you compile all this data, all these digitalized evidences, you compile it, and you make some basic statistics. And if you want to make some nice mean understandable graphics or dashboards, you use Power BI for that. But if you want to go further, no, then you need to, you have to create this model in the way we mentioned before. And with that, you will discover these issues that are these situations you will not ever to distinguish, discover, realize before with the technique. And this will help you to prescribe, and be predictive or be prescriptive, okay, on that. So again, all the main trainings for today is that you, after the training, realize that the world is explaining the past or inference about the future. Okay, this is the main question. Okay, so, well, what are the type of predictive analytics in the meaning of creating that prediction? So we have to analyze historical data to predict about future events. So here is one. It seems that artificial intelligence is a kind of magic. Or why we normally this magic is what we stay for this person inside the company that has a lot of knowledge or wisdom. They are kind of the gurus. So yes, artificial intelligence come here to try to settle what the guru says, or at least not to substitute the guru, but help the guru to be more productive and be more scientific on their statement. Okay, so well, these are the type of examples that the big one players of artificial intelligence want to do, and how are doing that. Good data collections, the outcomes of the events should be clearly defined, accessibility to data features related to outcomes, ability to learn data for good learnings, and complement capability to implement learnings via in data. These are the type of challenges or objectives that analytics has to have. So again, basically, when we talk about this predictive, what we have to do, data preparation, model training, validation, assess. Assess is when you involve the responsible, the guru, that type of person that take a decision based on his intuition of experience. You want to substitute that. That's why in some cases artificial intelligence is being seen as a pain, pain in the meaning of I will be substituted by a machine. Well, in some cases, yes. So here is where you have to involve the expert on the matter, the business responsible, whatever. And choosing means that finally you have to deploy it productively. That's saying that in another way, this responsible for assess the performance and the accuracy. You have to involve the guru. You have to involve the business person that it has been made made the investment on that. This person that has made the investment on that is what finally decides to go or not go. Not all the models that are being developed go production for different reasons. The accuracy that finally is being achieved is not enough. The velocity or the speed of the answer is not acceptable, what is expected. Kind of example, if a recommendator. A recommendator is something that when you are navigating through an e-commerce, you want that the recommendation of other options to buy or other complementary products you want to you can opt to acquire should appear at that moment, not once I have finalized the when I made the order. So that you see, if I am able to build a model that recommends something but it's so late, it's not interesting. So there are different reasons why sometimes the model doesn't produce, or sometimes it's a question of architecture of technology, something that we'll talk later. Means that you have not sized the information systems the right one to deliver the information and answer, because it will fail on the scale or whatever. Okay, but well, many reasons. Okay, going forward. So when we analyze, basically we have two kind of answers, or we are saying something that is Boolean, it's in this category or in this other, is in this size or is in this other side, or more values continuous, that you expect a value that is inside of a range. Okay, more or less. Like, okay, the new models about generative AI, well, are more closer to that. They are producing letters, all these ChatGPT and all these models that utilize natural language processing, let's say, are more close to this type of outputs. Okay, reviewing is how everything start with signals. You have to have a lot of bunch of data that you have to create. What are the, from all these columns that are values, you have to decide which ones, columns or fields or features, best explain, and later you have to create a model, and this model is what you, let's say, manage in the different experiments. That's why sometimes I talk about when you are producing the model to inference, you are in a kind of a laboratory. You are in a ceteris paribus, you are in an environment with a concrete data set. You are trying to make the inference and see if it's working. When you train the data, you made your experiment. Afterwards, you check about the validation data. You show to the manager, the executive manager, that has to decide to evaluate that, and later on you put in production. All this experiment is what you are being managed. Okay, so again, the data is what we call the signals, and that we put in a logical, and we produce some insights, Boolean or continuous. Okay, and this is the type of example. So for making the analytics, what you have to consider, it is the training data, the validation data, and the test data. It's another data that you incorporate to test your model. When you create the model, you split all the data in training and validation, and later you need more data to test that your model is working. Remember the scientific method. What is the scientific method? The scientific method is that you have an hypothesis, let's say challenge. You validate the hypothesis with some test, and this test should be reproducible by another way, another person. This way will say that your hypothesis is valid. This validation means that others are being able. In this case, is others means others data that you have from your initial data set are the ones that explain and validate your model. Tests will be related more with put it in production. The different predictive models, the different techniques of learning. Well, there are this small list that we will see more or less later. We will not go in depth in one of them because it's not. This is with Elisenda that we take 1 year to explain to the users to understand. So we don't expect that you understand the data on 5 minutes. But well, this is the less general classification of how these different algorithms or learning techniques that apply. Okay, so basically, when you start with rows of data and columns of data, and with that you make some predictions, and these predictions are, let's say, evaluated or ponderated. and some of them has a better accuracy than the others. This is how basically you do it in a algorithm. Let's very basically review the basics. Is what we call the linear regression, and then why you try to find, let's say, a trend. In all the data that you have, there is a, let's say, it's not an average, or more or less is this line that better describe what is the trend along all the values that you have. This will be a linear regression. The other is the logistic regression. This line, what we try to do is to classify in one type or another type. This is a very simple. It is a linear regression. So in a line, the line divides all the data that you have. The other case is decision trees. Because the decision trees, what you have is a, let's say, a classification of booleans that give you a value. Okay, this is a way on as we normally take decisions, and this is done by this type of algorithm. Okay, so to simply understand and interpret both numerical and categorical data, etc., etc. It's another kind of algorithm. These are generic algorithms that later on, when you decide to take, remember, we have some kind of data, we have tables, we have a challenge, someone that wants to know something, and you as a data scientist, what you have to do is, if these are the data that we have, I have to understand, and this is the challenge, what I have to do is to decide which is the better learn technique, which is the better algorithm that would fit in the expectations of the explanation. This is something that you have to decide. So here is what the data scientists take place. Neural networks is that we don't have only a tree, but we have several and millions of trees, and these trees are propagated with more than one level. These are the hidden means here. That's what we are saying, that one of the issues with intelligence and artificial is that cannot explain about the results. And the main differentiation is when we go to an expert and we ask him or her, explain me how you achieve this value or sentence or whatever, or inference, he's able to go to the formula, to the rules, and explain us how this value is getting. When you are using this type of neural networks, you are not able, you as a person, you are not able. And the algorithm internally is being using the weight on different values and finally producing a result. We are not able, and the algorithm not also. Random forest is another. It's calling. Here is the using a multitude of random decision trees. Random means that everything is tested against everything. So yeah, it's some of the statistical techniques that are applied here, you will be able to reproduce, but maybe you will take years to do. So here, the question is, you have a lot of data, you have a lot of different data, and you have to give me the answer now. So that's the challenge. The only way to achieve that is with mechanicals. Mechanicals mean machine means computers. Computers with the different processes. Okay, and the last two, the gradient boost machine, that is another, is similar to random forest, but there is a small decision trees that are contribution. These filters are sequentially growing using information the problem growing. So as you can see, linear, logistic, and decision trees, and when you exploit the capabilities of the computers to multiply the managing of different trees is when you got all these other techniques. Okay, and well, last but not least, the examples are group of learners. So before I have explained that there is one model that uses an algorithm to produce a result, and sample is when I use different models. In fact, in some cases, we talk about meta models. Meta models more means that the final outcome, the final result of the inference is being done using different models that explain different parts. For example, in the case that we have seen the video of General Electrics, there it's a meta model. There are some ensemble techniques because one of that inference and explaining, the other is making the forecast, the other is creating the financial perspective, the other is what is generating all these text results is being converted to voice, the other is the voice that of the speaker that is converted to commands that has been extended. All this is a bunch of different ensemble techniques to produce this model, the whole model, that synthesize, that represents, the synthesis means not all the issues are taken into account, or not all the, let's say, all the facts that will happen around are taken into consideration, and only with some representative significant values you take a decision. Okay. And last but not least, okay, you have this. You have to have in mind that always you have to validate and train, validate, and test. So the graphics I put at the beginning, you have to have in mind that these data scientists work with these examples. When we go to the medicine and doctors, when a new drug is being tested, what they do, they make a kind of clinic, and they put some others give a placebo, and the others they give the medicament or the drug, the active principle, to test if it works or not works. So this is some of the statements that applies here in the data sciences are not completely new. In any case, what I recommend if you want to go deep is that well, there are some visual, even though to better understand ways to enter on that. Okay. I have repeated the last one. No. It's a confusion. There is the values. I see. I made the wrong photo. Okay. Yeah. So again, when someone talks to you about I made a model, well, you learn something today more than before, and you can ask to get some knowledge on your interlocutor which algorithm you use for that. Okay? Well, saying that, well, we have seen what is big data, the artificial intelligence, and contraposition with the big data. We have seen that for apply intelligence, artificial intelligence, apply means to build up a model. We have to use data. This data should be split in validation and training, validation, and test. But you have to apply, decide as a data scientist which is the algorithm that we want to express. Okay. Sorry, I see a hand. There is a hand there. Yes, no? Oh, maybe I see rapidly. And let's say in the half an hour that is remaining, well, let's see some, let's say, examples. Okay? Someone of you know about this product? Raise the hand if someone of you have heard about this product at that moment. Yeah, there is one of the panelists. Adria. Okay, later, Adria, I will give you a chance to enter, and you will give you some example. This is a, let's say, product of Amazon does not exist really. They remove it, okay? But the idea is this small, very small device that you put it together near in the same place where you have these different products, and when you push the button, it creates automatically an order of shop order. So this is the ultimate way of convenience. Nowadays, what happened? Well, if you have this product was before Alexa. Once you have Alexa, there is more convenience. So here, what is important to know is what happens? Yeah, here is the mouse. That Amazon, it's a machine. Everything is a machine to process your data from the shops, from the devices, for whatever, and they storage, they compute, they optimize it, and they finally have the outcomes that they have a way to represent. As you can see, the concept of analytics inside Amazon, how they do it, and how you can use Amazon to do that. Okay. Another case is it's an introductory review of these cases. Another company, Netflix. Okay. This is the amount of data here. Netflix. The chance is not only all the data that I need to send you the video to your home, but all this operation has been tracked in such a way so the new products are produced based on the, let's say, the recommendations, or the opinions of the previous customers. Okay, and what they do, not only they produce products, this series was produced based on that, but they also are able to produce some information in real-time data. It's what they do. It is that, I don't know if you know it, but depending on your profile, Netflix is showing you a board of the film, or in this case of the series, depending. Okay? So it's not let's say a front of a film, one generic for everybody, but it produces for you personalized. It is being customized for you, depending. So what does it mean? The last time I heard about is that for Netflix, there are 145 segments of a customers. 145. The last time I heard, I guess, was 2 or 4, 3 years ago. That means there is no one, even though it's a chief marketing officer at Netflix, for sure, I didn't know who it is, is not responsible, the person habilitated to give the answers. There is no person deciding how much segments or profiles of customers there is. There is a machine that is being tracking all the type of consumes that are inside. It is being produced this clustering of customers, and is creating this 145 clusters of customers. This could be done only by a machine. No human is able to do that, and also being quite representative. Okay, so let's see some reference, some applications of the technique. First of all, as I mentioned before, and I make a recap here, is how we have splitted the different references. We have split it in product, manufacturing processes, sales, post-sales, and after services. Okay, what has been. First, before going in deep, is what is happening, and this is something for another seminar, webinar, is you have to start to thinking. Remember that I said at the beginning, the word features that is being used in the data science methods about the feature engineering. Feature engineering means which attribute, which measure we take as significant for incorporate in our model. This is feature inside data science. But if I want to talk with you with product manufacturers, what is important is that your perspective about the product as a bunch and categorize functionalities of your product, it changes to features. Why? Because if you incorporate all these extra functionalities as features, because are the features that your customer perceive, because are the features that your employee perceive, etc. All this is the new way to understand your product. Yeah. So I will remain using the word product, but behind the word product is more the concept of systems more than a product. Okay. So product, understand it as a sum of functions. The first case, I guess it is interesting to share with you of the usage of artificial intelligence is in the creation of materials. So nowadays you, maybe you go to the raw materials to produce your products, assemble your products, and you go to a raw materials producer. So, well, you take for granted that these are the materials could exist. So, well, what opens the generative AI? What chance open is that you define new materials, the process of generating new materials, okay? The other is that you use generative in the CAD to produce new shapes of a product. The shapes of the products, the function of a product, the form, fit, and functions, the traditional form, fit, and function, and defining a product, basically the shape, was based on the materials that can have and the way you have to manipulate these materials. That's why when the appearance of the 3D printing or additive manufacturing, in contraposition of the extractive manufacturing, what opens these new tools is the ability to generate shapes that are impossible with the traditional methods of manipulation. Here, the 3D printing appears as a new technology to generate that, okay? And you need a tool, a CAD tool, that allows you to create this kind of lattice to produce new shapes of your product. Here, AI is, let's say, incorporated. Another thing is that you take that for granted. In the case this, I put it in here. If you can see later, you will be able to see this video that presents the different type of lattice you can produce, okay? The other case that appliances intelligent and artificial in the product is that you start to understand the service and you start to, let's say, you start to let's say, thinking on the product as a service that will produce some occupancy. In this case, we share with you this paper that explains this case. Okay. And the other, and here I will hand over to Adrià, that is going with us, the case of Kumux, and how they have applied artificial intelligence inside the product to create a service or system. Adrià, are you there?
Yes, can you hear me?
Yeah, sure. So I go to the next slide. You maybe explain.
Yeah, okay, perfect.
Behind having the chance that you are here with us.
Okay, perfect. I will do a brief introduction about me to give context a little bit.
Yeah, sure, please.
I am Adrià Ferran. I'm a physicist and I hold a PhD in applied sciences. And I also co-founded Kumux with two other colleagues 7 years ago as a spin-off of the University of Barcelona. And Kumux was born with the mission to increase people's health using dynamic lighting systems. And the idea is to generate data that we then integrate into control systems to provide the right tones and lighting levels, basically to stay in synchronization with the outdoors, following the natural cycles or the circadian cycles of light. And here in this slide on the left side, you can see an example of how we work in a hospital, providing different brightnesses and hues depending on the time of the day. I want to share with you some examples of how we use the data to create new algorithms and use machine learning models to make projects related to circadian lighting. Our relationship with data is intense, I would say, intense from the very beginning, since we started working with multi-channel luminaires capable of generating millions of combinations. And we even did an European project where we were given access to the Barcelona Supercomputing Center to perform luminaire simulations, generating files with billions of combinations with a size of hundreds of gigabytes. And in addition to generating data, we have also been analyzing, filtering, and processing data from other organizations and companies to perform our own studies. And here we have two different examples in the middle of the slide. At the top, we can see data from thousands of commercial LEDs from the market, from different brands that we have used to analyze new LED technologies and to compare them with traditional LED technologies. And at the bottom, we see data from sunlight at different astronomical observatories around the world that we use to provide geolocation capabilities to circadian projects. And in both cases, we have had to do an intensive standardization work to then be able to apply the equations to perform the calculations of our interest, basically. However, our last development, which you can see on the right side of the slide, is an algorithm that I think is the most interesting because it is a model-based machine learning. And this algorithm is able to predict the circadian parameters of luminaires that are usually very difficult to obtain from lighting manufacturers. And I'm not blaming them for it. It is simply that very few people ask for it because in most cases, it is data that has to be obtained specifically for a circadian project. And in this case, we use random forest algorithms to predict this new data we need. So in this case, and just to conclude, working with data, we have managed to overcome an obstacle that for us was a pain, since without obtaining the circadian parameters of the luminaires, it is impossible to know what will be the best circadian impact as the physiological level of light is seen for the users of a space. So starting from common data of a luminaire, such as CCT and CRI, that are common parameters that every lighting manufacturer has, we can predict everything we need to maximize the health of people in spaces through light. And finally, if anyone is interested in seeing the technical details of this last prediction model, you can consult the technical article published in the last issue of the LED Professional Review magazine, or contact me on LinkedIn, that I will be glad to share it. So thank you very much.
To you, Adrián. Just a small question. I don't know if you are prepared. Can you give us a rough magnitude of how much time do you take to produce that model? more or less?
Well, yeah, it depends on the different models we can see here. The first one I showed you, this model that we have several commercial white LEDs. We spent several time because it was, I mean, the work was really hard to obtain the data from the different LED manufacturers. And it was not only contact them and asking them for the data, but was also related to make scrapping, web scrapping, to get this data. Then we could see that this data was not standardized between manufacturers. So we spend a lot of time basically standardizing everything, putting everything in the same way, to then begin to analyze and provide all this information to our customers. And with this model, we spent something like, I don't know, maybe 1 month, but an entire month developing and getting the data, filtering, processing, and everything. The next model, the solar model, I think that here we spend a lot of time also getting the data, because we have, I mean, we are a spin-off of the University of Barcelona, and they share some data with us here in Barcelona in the Faculty of Physics. They have a small astronomical observatory. But we have had other data from other places in the world, because we understood that it's not the same data you can have in Barcelona that, for example, in Colorado. That is another huge data set we have. And because here in Barcelona, when there's the sunset, there's a mountain in the middle, and sometimes if you are pointing at the sky, you will have not the best data due to this mountain blocking the sunlight that directly goes to the sensor. So we needed different sites over the world, and we spent a lot of time looking for these sites, and then again standardizing the data was something that we spent a lot of time doing it. And then obviously here we have thousands of hundreds of thousands of data points. So we have had to develop models that work fast enough to, let's say, to process all the data, and then conclude with a small model that can be used in production to a web server. That is something important to be into account, that you can have a lot of data, but then you need usually a simple model to be ready for production, because you want this model to be fast. Because if your client spends, I don't know, minutes or even hours to get the results, it can be a pain point in terms of business model. So the idea is to simplify this model and have it on the cloud. And finally, this last machine learning model, I would say that it was quite fast. I mean, we spent maybe 1 week developing it, and we used a random model algorithm to create this model that basically is predicting circadian parameters from colorimetric parameters of the luminaires, which is something that it wasn't published before in the state of the art. So yeah, I mean, this is, I mean, the most complex model, I would say, but it was not a lot of time that we need to spend to develop it.
Yeah. Okay. Thank you very much.
Okay. Thank you
for sharing that. And in any case, okay, what is relevant is that getting the data, the right data, normalizing, standardizing to having a model is what it takes more time than in the definition.
Yeah, usually people are talking about creating new models, but actually I think that the most difficult part is to get good data and standardizing this data and be all prepared for creating this model that finally is not a lot of time. Let's say it like this.
That's something that we realize with the students, but when they go to the companies and they say, hey, here is a lot of stuff to do, to prepare, that I thought that it will be go there and succeed, and they see that that is not the case, and within the other project. Okay. Thank you, Adrià. let's go for the next. We have only 20 minutes. There is another case that is the pedaling from SETE. Here we have, and they have also created this remote assistant, but here, better than a video, is that Gloria Torner from SETE that has the chance to explain to us what is behind that, or at least give us some clues on the project.
Exactly. Hello, everybody. I present and introduce myself. I'm Gloria Torner from SETE. I'm a business developer manager, and I'm going to tell you that we've been like nearly 2 years working about introducing big data and introducing artificial intelligence in our operations. SETE is a company that we work in the streets. It's street lighting and city technologies. So our aim was to anticipate all the problems in the street, to anticipate the failures of the lamps and in the street light, and that was our main aim. Yeah, if you want to check the video is in Spanish, but you can play it, Carlos, if you want.
Yeah. Okay. So
the problem is that it's in Spanish.
Yeah.
Thank you, Carlos. Yeah, thank you, Carlos. As I was saying, our aim was to minimize or reduce as maximum as possible the problems in the street and be able to anticipate the behavior of the infrastructure. So we started with Predalin, this project, and we realized what you already said, that there's a big difficulty of standardizing data in order then to be analyzed. So we started gathering all the information first in our databases, because we are a company that's been operating in the streets for hundreds of years. So we had a lot of information. Problem is that information in our databases were not standardized and were not ready to
be analyzed
in that way. So we had a real problem there, and we started to categorize and standardize and understand the information, and then also, meantime, the streets, the public sector were starting to put a lot of devices in the street that were generating more and more information every time. The devices that are in the street now, they usually in a street light in our sector, we gather information every 15 minutes. So there's a big problem of big data. It's big data and big problem too, to analyze and standardize, keep and reject information that it's not useful. So yeah, it was a challenge. It's been a challenge. Now in the phase we are already training a model. We are now in that phase. Carlos explained it, all the phases in introducing artificial intelligence. So now we are training the models. We had to spread this. Predalina and Lucia are quite related. It's more or less that they are different projects, but they are quite related. Because Lucia is an intelligent agent that we put in the cabinets in the street that controls all the street lamps, and also other devices that are in the street, as for example contamination or any sensors, any kind of sensor to count the vehicles or to count people or to count whatever. And what we do with this, with Lucia, with this remote assistant, we gather all the information, and we try to, first of all, to read it and see the, how do you say it, how related they are, the impact in if the temperature is higher, do my probability of failure increases or stays exactly the same? After analyzing all these parameters, because we have a lot of parameters from operations, parameters from the street lamps, for the type of light, the type of how they, which preventive activities they had or which corrective activities they have. Also with all the meteo information, the forecast of raining, the forecast of high or low temperatures, all this information. And now we have developed these models that we are now training. So now we are in the phase that we are seeing the behavior and checking the accuracy, the accuracy, because accuracy is not still the one we want. I think that we are more ambitious, and we are still learning also with the computer and with all the computing systems. So this is how we are now, but this is already in the streets. We are already gathering information from the streets, and and seeing all the correlations in between all the parameters. So it's very interesting, and we think that it's the future, because this agent Lucia can also take their own decisions. Not yet, because we are still training the model, but can already, without saying anything to him, if the agent must switch on before or later in order to help the consumption, the electric consumption, is going to do it. That's our aim, that he can make their own decisions. For the moment, we have it in several places, just in Catalonia. For the moment, it's just in Catalonia, but in cities as Tarragona or other small places. But yeah, it's a reality already.
Yeah, great. Fantastic. One small question different to the Adrian, not about the time, but this experience you have developed it inside, or you have externalized to a specialized company to make the data scientists?
We externalized it. We started a project with Eurecat, that is a Catalonian technological center.
Yeah, you mentioned here.
As we are experts in street lighting and in operant and maintenance, we contacted with Eurecat, and they helped us to understand our databases, understand and all the technology available, and we did it together. Yes.
Okay. Yeah, I asked this question because if I have enough time later in the strategy of how to apply, this is something that should be considered for the companies. Yeah, after the training, I guess I have understood something. I want to start how. So you need some help for that. Okay, Gloria, thank you very much for sharing your knowledge on that. Thank you.
Thank you very much to you.
Well, there are still 10 minutes and some cases here. We, together with Elisenda, we gathered that about furniture, not only light. Furniture is more difficult to find some cases, but here, well, the idea is, again, you sensorize your furniture. In this case, it's a chair, and with that, what you expect is to create a understanding on the product. Here, the expectation is you can connect this chair with the games, or you want to make it more economic, whatever. So it's something that we have not mentioned, but creating this new product that are platforms or system, it allows you to create a new model, service models or business models, even though. Okay. Going faster regarding the processes. We have talked about the product, we have defined a product, we have created a future service based on how we consider the product. But if we talk about the processes that make it real, I want to share that image with you. I don't know if you are aware, but we are here. We are in a complex world, where we have to cover a lot of requirements. We have to cover a lot of the expectations for the customer, sustainability, etc. So it is difficult to manage, say in another way. In this case, with the cancer. So basically, what is happening here that this is not the current situation. Maybe it's an old photo, but the current situation is that you should start to be thinking in service more than manufacturing. And service means that you serve, you deliver on time with quality and innovative. You deliver on time, personalized, very personalized. For here, I give you this paper about Nobilia. As you can see, it's 2014, so it's quite old. So where they are applying these techniques to the production. The production is being planified and is being decided automatically and executed automatically. Another case of operations is this case of Simon, that is being, let's say, focusing on the supply chain. And say, hey, how will be my expected demand and functioning my expected demand, how I have to make the acquisition. So this is made with some predictive algorithms to figure out how will be the demand. Other cases like this, and in these cases you have you produce the PCBs or you subcontract and you analyze. In the case of equity brands, they are doing something similar. During the assembly, they are inspecting on real time if the PCB it's okay or not okay. And in other cases that I share with you are not from furniture or lighting, but are companies that are similar issues, that they have a variety of portfolio, they have reduced lot size, and this is increasing the complexity of understanding what is happening at house. So all these appliances, not only with some methodologies, but having these appliances with the digitalization. Many of them are related with digital transformation projects, okay? And many of them, wants to give real time. In the processes is real time. In this case, even though it's related with the PLM, so what is being produced is linked with what is being designed for the process, so everything is connected real time. Other companies, in this case of food, what they would want to know is real time what is happening, because in this case, the size of the load also are being shrinking, so it's been small and small, and they want to know what is happening. Or in this case, okay, here, in this case, it's an experience that we have with the PTC, even though there has been structured in different cases, or in this case, this is Skoda. I know this is automotive, but sometimes these sectors are quite inspiring, where they are going further, okay, utilizing, in this case, augmented reality to figure out. Here, as you can see, there are not screens, but all the information is being posted in the tablet, and the information is being shown regarding where you are pointing with the tablet. Okay. Some cases about the operations, others about sales and post-sales or service. Here, the idea is that how about automate the process of sales. One, let's say, it has been mentioned in the two previous cases, this normalization of data. What happened with a company with a lot of record, many years of activity, that the data that has been gathering alongside the time, it's very diverse, even though it's the same company. So processes like activities like that, at first, before making any prediction, we have to have a standardized information or data standardized and information standardized to make some predictions. This will be one of the other cases. The other case is to apply artificial intelligence in the recognition of the space. And as you have seen, IKEA, but also Amazon, it's even though to facilitate the automation of the sale, to facilitate the process of decide that you want to buy this product, to take the decision in place. This will be another case. Or in this case, that even though it's more than selling the furniture, but also seeing how will be fit inside your ambient, and helping you to decorate with all the components that you have, some real and some unreal, but they can produce the order. Or in this case, what is being made is generating the appearance of new products, and this generating is being made with artificial intelligence, and this is the start of the order, or how it will be processed. In this case, it's a company, they have their solution, and they will fit inside you. Or one of the cases, other cases in the automation of the sales, as Cabe Home is been doing for impacting. Here they have started a very strong sometimes before, now to selling online. They are mainly distributors more than manufacturers, even though they subcontract a lot. So here is that they have a very rotation of their portfolio, so they need to impact in the right way. So here they are using that for making customized. So here you have to have a very segmented perspective on your customer data. Other cases will be the chat box. That means that you interact with your customers. You interact in a, let's say, automated way. So here is you apply a chatbot. In this case is kind of Alexa, but the Alexa that we have seen in the beginning is you have to think in Alexa partner of your product, because when it will use it will be, but here is about in the sales process. Okay. Here I share with you another case that is how you can build up a chatbot. Okay, this is a company chatbot that help you to create your own chatbot, or you develop it inside, or you can use tools like that integrate with your system. Okay, and I wanted to add that at the end is why I wanted to add that reference here is to say is these new technologies, these new chances opens to a new incumbents. When all of you think about what are my competitors, if you are in the furniture sector, you see all your competitors. Or you are in the lighting sector, you think about all competitors. But if you enter in the area or in the scenario of services, what happens? New incumbents appears. Right? So you never expect that Vodafone will be your provider of mobile, but never you think about Vodafone as your competitor in the service world of managing lights. It can happen. Here, that's last message on that, I will give you this an overview. There is a section. It is 12. I will not able to finish on time. This is a section about the strategy. Well, there are some slides. The important for me is speed. It's not a question of matter today of quality of innovation that it should be related, but it's not about the speed or velocity, better understood. The able to respond. As I mentioned before, it's not a question of it's a question of adaptation. Here is the fastest who wins. Okay, this is a process of extraction. Intelligence means that it's a process of extraction, and you have to understand that inside the company. So you have to have in the analyticals continuum, as I mentioned before, and this is what most I like. This cannot be done with paper. Paper is a technology. It's a 0.5 technology. It was invented by the Egyptians, but that is not the technology. And even though Excel is paper, it's digital paper, you have to think in a data-driven company where you have all the data you have to gather to produce new perspective and retrospective. You have to think about your product. You have to define how later will be applied. And this is something that other companies have started. And I like this mention about the difference between digitization and digitalization. Here is censoring your products. And once you censor your products, you can digitalize your company and create a new model of reference. You can create a new business services and business model because you have incorporate this technology inside your company. And last but not least, think about this technology, this intelligence that you put automatically, what will help you to know more about what? About your product, because you want to sell more, or about how you do the things, because you want to be more efficient, spend less. At the end, everything is based on the same. So think about the architecture, how you will structure not only the functions of your product, but all the features you will have to deploy on that. And you can do it by your own, or you can choose one of the, let's say, hyperscalars that are there. They are there, Amazon, Google, to provide this infrastructure to deploy this architecture, or you can do it by your own. This is the statement of this company. In any case, and for finalize, you have to think about your product as an asset that should be administered. This will give all the functionalities through a method. This is something called that we call the API. This API will give you your access, your products internally, externally, and whatever, and in this perspective of systems of intelligence. Here in the last century, there was the effort on systems of record, storing the data you need for answer your business. Afterwards came the web, the mobile, this open that the public, the consumers can produce data, and you have to gather the information. And nowadays, you have to understand what is happening behind. Many of you, as for sure, have a lot of information, but knowledge, few. So my last slide is, well, think about, make a statement where you are. Here you have a reference of the Industry 4.0. For you understanding, 80% of the German companies are here, 80%, the all sectors are here, and only 20 are here. So, well, there is a lot of job to be done. Check or compare that about the analytics continuum to how you expect to deploy that technology inside the company. And very rapidly, more or less, I try to finish on time with 5 minutes delay on the time expected. But I hope that at least you will have all the material. If you have any doubt, you can check and contact me and Elisenda, and we will be very happy to go deep with you in some of the cases we have shared with you, and hoping that has been interested and fruitful for you.
Thank you very much, Carlos. Thank you everyone for assisting to this webinar. So if anyone has a question, please raise a hand and I will open your micros and you could ask something to Carlos or some of the other panelists that present the solutions.
Gloria, yeah.
Or you can chat if you prefer not to speak.
Well, at least raise the hands. Those that has been fruitful for them and are happy to having attended the very fast and rapid attack of the session. Well, I don't know if in the presentation was our email, but through you, Andrea, we'll be able to answer any doubt and question that could
I will send the
arise.
presentation, the recording to all the participants will be available also in our internal space on our website, together with all the seminars that we have developed in Sileo. So, and also I will share your contacts and contacts from everyone that has joined this meeting. Thank you very much, everyone, and I hope to see you soon.
Okay, see you soon. Bye-bye.
Bye.
Bye, see you.
Bye, see you. Thank you.
Thank you very much.
Thank
you. Bye.
Question or not?
No, there were some
Okay.
some mentions in the chat.
Okay. Okay. Thank you.
See you. Bye-bye.